Welcome to the port scanning lab. Now, port scanning is an activity that is performed both by the defensive side, that is cybersecurity professionals, as well as the offensive side, the hackers. Now, this activity allows you to discover ports which are open on your system, and it also allows the cybersecurity professionals to consequently block services which are no longer required in order to harden the security. Nothing beats security more than a vulnerable port open on your system. We are going to conduct our lab using the Nmap tool. It is a simple yet powerful tool which allows port scanning in a wide range of scenarios. Now, port scanners are an important tool in any pen tester's armor, and it helps identify open ports as well as the services running on those ports. So for example, if the port 23 is open and the telnet service is running, so the port scanner is going to inform the pen tester that both the port is open and the service is running. Here is a list of some common services and their ports. So FTP runs on port 21, SSH, the secure shell, always uses port 22. Telnet, which is a very weak protocol and transmits data in plain text, transmits on port 23. SMTP runs port 25. The domain name system runs on port 53. HTTP, the protocol used for web browsing, and an insecure protocol because it transmits data in plain text, runs on port 80. The secure version, that is HTTPS, runs on port 443, and SQL runs on port 1433, and so on. So all of these are standardized ports. Now we have multiple types of port scans, but generally speaking, we either employ TCP or UDP port scans, or we also employ stealth scans. So the basic difference between these scans and stealth scans is that stealth scans try to launch scans which are not easily detectable. Because for example, if you do a lot of port scanning, so basically you're obviously sending messages and receiving messages, right? You're probing different ports. So any of the security tools at the destination server, it can trigger an alert on those tools and you could be discovered or blocked. So let's have a look at some of the commands used for port scanning. First of all, we'll see how we can scan 1000 common TCP ports. So the command used is nmap, and then either you can specify the range of IP addresses using the mask. So for example, this says that 192.168.1.1 and then the mask 24. So all of this range of IP addresses would be scanned, or alternately, you can specify a single IP address, in which case the 1000 ports would be scanned for this system only, whereas in this case, the common 1000 ports would be scanned for this range of IP addresses. Let's have a look at the results. So we have launched Nmap scan on a single IP address, and here are the results. So basically 3 ports are open. One is for HTTP, one is for IPP, another one for MySQL. So all are TCP ports because we have launched a TCP scan. And we also see the port numbers here. And we also see that there are 997 closed ports. So not only we found out open ports, we also found out which services are running on those ports. So next is how to scan all the ports on a destination IP or a range of IP addresses. And it's really simple. We just use a special flag which says that scan all the ports. So as the results show, we find 3 ports open as previously, but this also shows the remaining ports which are closed, which is 65532. So basically this scan basically probes all the ports on a destination and informs us about all the open ports as well as the closed ports. So sometimes we are just interested in scanning a single port, in which case we simply specify the flag -p and then we specify the port followed by the IP address which we want to scan. Now why would we want to scan a single port? The answer is actually quite simple. Sometimes attackers, they don't want to leave a big footprint. If they're scanning a lot of ports, this leaves a footprint and it can trigger alert by the intrusion detection systems or the firewalls at the destination. So basically, in order to hide their tracks, in order to operate in a stealth mode, sometimes they just probe ports which are known to host weak services. For example, port 80. HTTP now transmits data in plain text. So if you just want to see whether the web server supports HTTP or not, you can simply scan port 80. Similarly, you can also scan port 23 to see if the vulnerable service telnet is working or not at the destination. So the results for this scan just simply reveal whether port 80 is open or not. So next is fingerprinting the operating system. It is very important for the attacker to find out what he is up against. So a lot of information can be gathered and he can, customize his attack if he knows the exact operating system which is running on the destination server. So for this, Nmap can again be used using the flag -O. So for the output, we see which operating system is running. In this instance, we see that it's a Linux kernel running on the destination. Now this gives a lot of firepower to the attacker because once he knows the exact operating system and the version, he can do some research offline and find out vulnerabilities or known weaknesses of that operating system and then target the attack. So next is discovering IP addresses. Sometimes the attacker is just interested in find out the identities or the IP addresses of all the systems within a subnet. So for this purpose, a ping scan or a ping sweep could be done. So this is done by specifying the flag -S_P, which tells Nmap to launch a ping scan or a ping sweep for a range of IP addresses, which in this case is 10.0.2.0/24. So as the results show, we are going to find out all of the IP addresses which are up. So for example, we see that 10.0.2.2 is up, 10.0.2.3 is up, and so on. So this basically tells us all of the IP addresses which are available. So basically, since we used a mask of 24, therefore Nmap is going to scan 256 different IP addresses or different hosts, and it's going to tell you how many of those hosts are up. So now we are going to move to the virtual machine and do a practical demo. After that, some tasks would be assigned to you to complete on your own. Most of the labs in this course will be conducted using Kali Linux virtual machine. Instructions on how to download and configure it on your system are already shared. Now, Kali Linux is a popular VM which is extensively used by offensive security professionals in order to carry out penetration testing. It contains a lot of tools which make the job easier. So for each individual lab, we have shared separate lab documents which detail the steps that need to be undertaken and some of the additional tasks that you need to perform. So let's start our lab. The username and password are Kali. You need to go to information gathering and then network and port scanners, and we launch Nmap. So anytime that you need help with the syntax of any command, just type Nmap and you can see the list of commands, some examples including the syntax, as well as the manual page. So our first task is to use Nmap to do TCP scan of the 1000 most common ports on a system. Please keep in mind that we are only allowed to do port scanning on systems that we are authorized. So we are going to do the port scan on our local system. So our first task is to do a TCP port scan of the 1000 most common ports. So we do this using Nmap and then we specify the destination, which is our local host. So the results show that we have 998 closed ports, only 2 ports are open, port 80 corresponding to the HTTP service and 3306 corresponding to the MySQL service. So our next task is to scan all the possible ports on our destination. So we do Nmap and then we use a special flag and then we specify the destination, which is our local host. As you can see, this takes slightly longer than our previous scan. We just scanned 1000 ports. So in this example, we see that we have 65533 closed ports. So basically it scanned all the ports, and once again port 80 and 3306 are open. Our next task is to scan one particular port. As discussed, sometimes the attackers, they don't want to leave a big footprint. So that's why they only probe specific ports in order not to trigger any alerts by the intrusion detection systems or the firewalls. This is done by using Nmap -p for the port, then we specify the port, which is 80 for example, and then we specify the destination. Now this is going to just probe port 80. Our next task is to fingerprint the operating system, but for this we need elevated privileges, so we're going to use sudo, then nmap, capital O, and then our local host. Kali is the password. Now as the results show, we are running Linux kernel 2.6.x. Now this gives a lot of firepower to any attacker. So once he knows the operating system and the kernel version, he can customize his attack based on known vulnerabilities of that kernel. Our next task is to discover all the IP addresses in our subnet. But before doing this, we need to find out the IP address of the Ethernet card that our virtual machine is using. So for this we do sudo. Once again we need elevated privileges, and then we do ifconfig. Now if you see the results, we see that the Ethernet card is using IP address 10.0.2.15 and it's using a 24-bit mask. So what we do is that we do nmap minus sp. So this is basically a ping sweep or a ping scan to discover all the IP addresses within this subnet, and then we specify the IP address, which is 10.0.2.15, and then we specify the mask. This is going to list all the hosts which are running in our local subnet. So as you can see, we have 10.0.2.2, 10.0.2.3 and so on. So this lists all the systems or IP addresses which are active within this subnet. But we can do UDP scans as well. For this you need elevated privileges, so do sudo, then nmap minus su, u is for UDP, and then the destination, which is the local host. So as you can see, we have done a UDP scan using the Nmap tool. So Nmap can be used in a wide variety of contexts for different types of TCP and UDP scans. We are now going to discuss the tasks that you need to perform. So the first task that you need to perform is to do a port scan of a particular range of ports starting from 60 to port 120 for your local machine. Instructions on how to do this are shared in the lab document. Your second task is to investigate if Telnet is running on your local machine. The only catch is that you are allowed to scan only a single port. This concludes our lab. I'll see you in the next lecture.